All right, thank you so much for joining us today. So, in the previous video, we talked about exponential function, the natural log function, and then the log function itself. And then we've talked about, constant rule, power rule too also. In this video, we are going to focus on other rules, different rules that we can also use to differentiate functions, right? So let's start by talking about change rule. I know change rule is kind of very popular, change rule, change rule. But in change rule, I've grouped change rule into two. And then I'm going to show you how to use the change rule for the functions. Now, this first one that I have here, this change rule formula that I'm going to show you here, it's kind of this, we are going to apply this to the trig functions. Basically, like this kind of change rule, I love using it for the trig functions, right? So you will see that I will show you how to use this change rule for doing trig function, and we are doing trig function too in the same video. And then when I finish, we have some examples that we are going to go through, and then I have some trial example that I'm going to give you to also try and leave your answer in the comment section. So stay here with me. So with this one, if I have y is equal to gen of x, this is like change rule, like a composite function. So this is how the rule goes. It says that if I want to differentiate this function, then first I need to differentiate the out function, which is f. So I differentiate the out function, which is f prime, but I'm not going to touch what is inside the brackets. So I just did something to the out function. When I finish, I multiply this one to the inner function by differentiating the inner function and use to multiply. Then I'll multiply this one by gen prime of x. So this is the change rule. And as I said, basically we use the idea of this for a trig function. We will take example for you to see very soon. And then I'll be showing you how I'm using them. So please keep this one too in mind, how to differentiate, using the change rule. Now we have another change rule which goes for, the power rule. So this change rule is going with the power rule. Remember, we've learned power rule already, right? The functions that are in the form of power like this. But what is inside the bracket is also a function again, which is not x. Now we know that when I differentiate x squared, I'm going to have 2x. But we left some idea out. Why? Because I can put this x squared in bracket, right? Or x inside the bracket. And when I differentiate this, I'm going to have 2x. But when I finish, I will differentiate what is inside the bracket. And when I differentiate what is inside the bracket, I'm going to have 1. So we left that idea out. That's the reason why we don't see the chain rule for the power rule there. So this one, we are using the change rule for the power rule. So what will be y prime if I have f of x in bracket to the power n? This is first, we need to use the power rule. So what the power rule says, y prime will be drop the n, don't touch what is inside the bracket or the square bracket, and subtract 1. Remember, this is the power rule, right? Then when I finish, change rule says that we are assuming that the function here, when we differentiate, we are not getting 1. So we need to make sure we differentiate that function. If not, our derivative or our differentiation will not be complete. So this is also another formula that we need to learn. So now we've learned 2 formulas here. Good. So this, as I said, this is for trig functions, and this is for power rules, which is having a function inside, which is not like when you differentiate, you are not getting 1, right? So basically, this is the change rule. Now let me talk about trig functions, and then we, basically start the idea of practice. Now, these are something that you need to know it off head. So I'm going to write it for you. Know it off head, because it's kind of like something that you don't need to prove. Like, remember, we use limit definition to prove this one, that when I differentiate sine, I'm going to get cos x. And I gave you one example to solve. So if I've done it in that video, you will see that when you differentiate, when you use a trig function, you're going to get minus sine x. So basically, this one, for us to prove it, we need to use the limit definition to do that. And when I differentiate tan x, I'm going to get secant x or sec x. And then when I differentiate sorry, this one's supposed to be squared x. Good. And when I differentiate sec x, I'm going to get sec x tan x. And when I differentiate cot x, I'm going to get minus cosec or cosecant x. So this one too can be written as minus CSC of x. So if we see something like this, that one too is true. And when I differentiate the CSC, which is the same as the cosec, this is the same as minus, this one should be giving us what? Minus cotangent squared x. Is that right? No. Yeah. Oh, okay. Yeah. I'm coming. This one rather supposed to be squared. So this is wrong. This supposed to be squared. So let me just shift this one small. So this kind of squared, and this is going to be squared x. So that when I differentiate this one is going to give us the cosec x cot x. Good. So this is something that you can write it down. You can just watch the video and write it down. Memorize it, like have it off head, like that. If I differentiate this, because whenever we are differentiating it and we see it, we just put it there. Okay, when I differentiate sec x, I get sec x tan x. When I differentiate tan x, I get sec squared. So basically, we need to have this one in mind. Now that we've talked about change rule and then the trig functions, just basic trig functions. Now let's take some examples and use the idea of change rule, right? So I'm assuming that this is now I'm teaching it. So which chain rule are we going to use for this? We are going to use the one which was giving us y is equal to f of x all to the power n. And we said y prime should be the same as n down f of x n minus 1 times f prime of x, right? So when we look at this function here, our f of x is this. And when we differentiate this, we are not going to get 1. So it means that we need to differentiate that. So it means that this is going to give us f prime of x to be. So first we need to apply the power rule, right? So the power rule goes first. So 5 drops down. I maintain everything in the parentheses. I don't touch it. Then 5 minus 1. So we are following the trend here. Then when you finish, I need to multiply this one by the derivative of what is inside the parentheses, because finding f prime was the f prime which was here. So this one will be d over dx 4x squared plus 2x plus 3. So this is how the process will be. And this is going to give us 4x squared plus 2x plus 3. This one will be 4 times this. When I differentiate, I'm going to have 8x plus 2. So this will be the final result for this when I differentiate this. So now when we are doing it, you see that anytime we are solving an example, we've talked about change rule. So we know that we are using the change rule. So you need to master it very well, that when I see the function, I know that this is the rule that I'm going to use. Is that right? Good. So that is basically what we just need to do. Now, let's talk about this one. When we started limit, I think when we were dealing with trig function, I said when you see something like sine squared x, this is not the same as sine x squared. So pay attention to that. But when you see this one, sine squared x is rather sine x all squared, right? So it means that for us to differentiate this, we need to use the idea of, like, we need to simplify this by writing this one as sine x all squared. Then we need to use the change rule that we just learned here, because it's something to the power n. So let's go through the process again. F prime of x will be equal to, so 2 will drop down. Then I don't touch the one in the parentheses, right? So I don't touch the one in the parentheses, and 2 minus 1, right? 2 comes down. Don't touch what is inside the parentheses, because I see that some people, when they are doing this, they will do it like this: 2 and differentiate sign and get cos, and then have this. This is like kind of wrong. So you don't touch what is inside the parentheses when you are applying the power rule for the squared. Then now when you are done, is now that you need to attach the one in the parentheses by differentiating it. Good. So what are we going to get? This is going to be 2 sine x times, when I differentiate x, I get cos x. And this is sine x cos x. And this one is a trig property, which says that this is the same as sine 2x. So when I expand sine 2x, which is the same as sine x plus x, using the property, you are going to have something like this. So if you don't know it, you can just stop here, but this is true. Good. So I hope you are, following, right? Stay here with me and let's go through the process. Now, you see this one is not like this one that we did here. So this one is the one that we need to use the first property, right? I said it's for the trig functions. So the first one that we learned. So we said that if I have y, which is equal to f of gen of x, then y prime is equal to f prime first, then gen of x times, now I differentiate gen of x. So that is what we are going to use for this function here. So here we are assuming that our f here is the first function here, what is the cos, and our gen of x is the one in the bracket here, right? So this is like f prime of x is equal to, now I differentiate first, the derivative will hit the function outside. So when I differentiate cos, what am I going to get? Minus sine. I don't change, you see that when I differentiate the one outside, the f, I don't change what is inside the bracket. It's still gen of x. So I need to still maintain the x squared plus 1. So what did I do? I just differentiated the cos and I have this. Then now I multiply it by, now I need to differentiate what is inside the bracket, which we are assuming that that is our gen of x. So I need to differentiate this. So this is going to give us minus sine x squared plus 1 times, when I differentiate this, I'm going to have 2x, and when I multiply, I'm getting minus 2x sine x squared plus 1. So please remember when to use the chain rules. So we have two of them, when to use this and then when to use this. You use this whenever you see that it's to the power n, the function is all to the power something. And you use this one when the trig function is just a composite function. For example, the one that we just did here. Now let's look at this one. We are still dealing with the trig function, so we need to use the previous idea. This is a quotient rule, right? So u divided by vn, and my u is equal to sine x, and then my vn is equal to cos of 2x. What is u, right? What is u? Prime. Now u prime, we know that when you differentiate sine x, we need to get cos s. We need to just have that one in mind. And then with this one, vn prime, this one we need to use the change rule. I mean the first change rule here. So first, the derivative will hit the first function, what is cos. So hit it and get negative sine x, but I'm not going to touch what is inside the bracket. Then I'll multiply it by the derivative of what is inside the parentheses. So I'm going to have 2. So this is going to give me minus 2 sine 2x. So you saw what we just did here. Differentiate cos, you get minus sine of the everything times, then you differentiate what is inside the bracket, you get 2. You get something like this. So now what is f prime? Quotient rule is vn u prime minus u vn prime divided by vn squared. So let's do substitution for that. This is going to give us something like vn is cos 2x, u prime is cos s, minus u is sine x, and then times vn prime is minus sine 2x, all divided by vn squared. So this one will be cos 2x all squared. If you want to do some small simplification there, you are going to have cos 2x cos s minus or plus 2 sine x sine 2x, all divided by cos squared 2x. So this is what we are going to get. I think we cannot cancel anything from there. So boom, that is what we are going to get from the top. So you see, as we are combining it, if you know how to differentiate like individual function and you know the rules, doing it is kind of very something that is very simple to go through. Let's apply the product rule because this is two functions multiplying each other. So I'll pick A, right, and pick B. So let's pick A and B. So what is my A? Let me assume that my A is equal to tan x squared and my B is equal to sec x. So what is A prime? So this one, we need to use the chain rule, the first one. First, the derivative will hit the tan, giving us sec squared. So when I differentiate tan, I get sec squared. I'm maintaining everything in the bracket. Then when I finish, I multiply it by the derivative of what is inside the parenthesis, which is going to give us 2x. So this is going to give us 2x sec squared x squared. You see that it's very simple, right? Yes, it's very simple. Good. Then when I differentiate sec squared, what am I going to get? Sec squared, we just need to have it like sec x tan x. That's all. So product rule, gen prime of x is equal to, let's say, a b prime plus a prime b, right? So just multiply them and then you are done. A times b prime is going to give us tan x squared sec x tan x plus a prime times b. This is going to give us 2x sec squared x squared sec x. Done. So is it that if you are very good and you know how to differentiate individual functions using the rules, it's kind of pa, then you are done. Right. Let's look at this. I love this question. It's kind of very nice. Yes. So this one, we need to simplify before we do it because we can see that there is 5 here. So please always watch the function. This one, you cannot say that this one is going to give us minus sine 5, 2x minus 1 times 2. This is wrong because we have 5 here. So this is wrong. You see that the one that we did here, this is 1. Like, it's not 2 or 3. So if it is not 1 here and it is more than 1, then you cannot use this one. So this one can be written as, this is the same as cos. So anytime you see a function and you see something here, write it like this, 2x minus 1 all squared. So this one, we need to use the chain rule, the second one. That goes with the power rule. So this is h prime of x. This is going to be, now let's apply the power rule. So we apply the power rule 2. Then I maintained everything in the parentheses here, right? Then 2 minus 1 times, now I differentiate what is inside the parenthesis, what is cos 2x minus 1. Good. So now this is going to give us 2 cos 2x minus 1, and when I subtract the 1, I just get 1 times. Good. Now that we need to use the first change rule. So you see that this question is using all the 2 change rule. Because we wrote it in this form, first we use the second change rule, which is applying the power rule. And then now when you come here, now because now this one is not having the 5 again, and this is like 1 and nothing is here, then now we use the first change rule. Now the derivative will hit the cos. So when the derivative hit the cos, I'm going to have minus sine 2x minus 1 times, now the derivative will hit what is inside the bracket, and we are going to have 2. So it's kind of very complicated. Now 2 minus and 2, this is going to give us minus 4, and I'm going to have cos 2x minus 1 and then sine 2x minus 1. So this is what I'm going to get. So it's kind of very simple. Just take your time. It's kind of, if you don't know how to do it, you can't do it. But if you know how to do it, then you can do it. So try and then understand the rules, pick them step by step. If you are no good, always go step by step. It helps you to clarify your ideas and then the things that you need to do. Let's do the last set questions, and I'll talk about how we are going to classify the change rule and then trig functions, and I'll give you a trial example to do. Let's look at this. So you see that this, it's kind of tricky. So you see that this is on this. So here we are not going to use the power rule. Since this 3 here is just on this function here and not on this or here, it means that it's on this one. So it means that here we need to use the first rule. So K prime, first the derivative will hit the cos, giving us minus sine. So we are going to get minus sine 2x plus 1 to the power 3 in times, then now derivative will hit what is inside the parentheses. So that one is 2x plus 1 cube. So pay attention to some of the questions. So this is going to give us minus sine 2x plus 1 to the power 3 in parentheses times. Now when we need to differentiate this, we need to use the change rule, power rule, right? So this 3 will drop down, 2x plus 1, 3 minus 1 times, then now you differentiate what is inside the bracket, which is going to give us 2. And this is going to give us 3 times 2 is going to give us 6. So this is going to give us minus 6 sine 2x plus 1, 3 times, when I simplify this, I'm going to have 2x plus 1 to the power 2. So this is what I'm going to get at the end of the day. So pay attention to the explanation and then do. I'll give you an example to try. I have a lot of examples for you to also try. Now let's do this one and then we talk about something small. There we go. So how are we going to do this? This is kind of like the power, the change rule again by going with the power rule, and we have the sum rule also inside. So f prime of x, let's apply the change rule power rule first. So 3 drops down, x squared plus tan x, then 3 minus 1. Then now I differentiate what is inside the parenthesis, what is x squared plus tan x. So now what am I going to get now? I'm going to have 3x squared plus tan x to the power 2 times. Now differentiate what is here. When I differentiate x squared, what am I going to get? 2x plus, when I differentiate tan x, what am I going to get? I'm going to have sec squared x. So basically this is the final result that we are going to get. So 3x squared plus tan x squared 2x plus sec squared x. Very simple. Yeah. So I have another example again. Okay, I think this is the last one. Yeah, this is the last one. Let's do this one and then I think we are done. Okay, I think this one is very nice. Let's do this one and let's go. So this one, for me to write, I need to simplify f of x. So some of the functions, you need to simplify them before. So this is kind of to the power 1 over 2 because square root of x to the power 3 plus this is this. So I need to write this in this form before I can use the change rule to do that. So f prime will be, let's apply the power rule. 1 over 2 drops down, x to the power 3 plus 2x, 1 over 2 minus 1. Now I differentiate what is inside the parenthesis, 3x cubed plus 2x. So this is going to give us 1 over 2 x cubed plus 2x, subtract and get minus half times, this is 3x squared plus 2. So that's what I'm going to get for that one. So it's kind of very simple to go with that. Now let's look at this one. Okay, so since we are talking about change rule, I think I brought this question up to, look at how we are going to do the change rule here. So they've given us f of 1 and then f prime of 1 to be this, and then they've given us gen of x, and we want to find gen prime of x. So for us to find gen prime of 1, we need gen prime of x first. So what is gen prime of x? We have this one to be 4, then f of x. So this is the same as gen of x, 4. This is the same as f of x, all to the power 1 over 2. So this is the change rule with the constant multiple and then also the power rule. So gen prime of x will be equal to, pick the 4 out. Now let's apply the change rule of power rule. So 1 over 2 drops down. I maintain f of x, then subtract 1 from this, times, now we differentiate what is inside the bracket, which is f prime of x. This is kind of very nice. So simplify this one. This one will be 2. 4 times half is 2. And this one will be f of x to the power minus 1 over 2 times f prime of x. So now that I've gotten this one, now I can look for gen prime of 1. So put 1 inside. So f of 1 to the power minus 1 over 2 times f prime of 1. F of 1 is 4, and then f prime of 1 is 3. So this is going to give us 2 times 4, right? Yeah. Then minus 1 over 2 times 3. Now this is the same as, so this is the same as 2 divided by 4 to the power 1 over 2 times 3. So this is going to give us 6 divided by, this is the same as square root of 4. So this is the same as 6 divided by 2, and this is going to give us a big 3. So this is the end of, I think, all the questions. Now, we are adding up to our general rule and then rules for differentiating individual function. So here we talked about change rule and we talked about trig functions. So we saw that, okay, indeed, like change rule, it's a general rule, like it's a formula that we need to learn. And we saw two things. One, we saw that if the function is of this form, let's assume that y is equal to f gen of x, then y prime should be f prime of gen of x times gen prime of x. That's the first rule that we learned from the change rule. And we also saw that if I have y to be equal to f of x all to the power n, then this implies that y prime is equal to n down f of x all to the power n minus 1 times f prime of x. So we also learned this one. So we are saying that this is just a formula. So anything that is the general rule is a formula that we need to learn. And then we talk about trig function, and then we saw that trig function is like rules for differentiating individual functions. So we know that when I differentiate sine, I get cos. When I differentiate cos, I get minus sine. When I differentiate tan, I get sec squared. When I differentiate cot, I get minus cosec squared. So we should be having all those things in our mind so that it will help us to go through our differentiation very well. We will add more in the next video to it, and then we will see how we can put the whole question together and we apply everything that we've learned in the video. So this is your trial question. I gave you the last one too that I did. So pay attention to that and solve them. So this is your trial question. Try it and leave your final results in the comment section. As I said, I appreciate all those that they solve it and then put their final results in the comment section for me to also reply whether you are correct or whether you had it, maybe you made a mistake somewhere. It's kind of a way of connecting and then chatting. Yeah, so in the next video we are going to also look at another rule. So you see the way I'm doing the video, and the time you will finish all the rules, you are the best to do differentiation. So see you in the next video.